In the spring of 1901, off a small Greek island called Antikythera, a crew of sponge divers plunged into cold, murky water. They had no idea what was waiting below. What they dragged out of the ocean made no sense. A lump of corroded bronze. Inside it, hidden gears, teeth like the inside of a clock. But this clock was 2,000 years old. Whatever they pulled up that day was older than the Roman Empire. It was older than Jesus. And it worked like a machine that would not be reinvented for another 17 centuries. How is that possible? A device built before the modern calendar existed, using engineering that was not supposed to exist for another millennium and a half. That question is the heartbeat of this story. Because the ancient world did not just leave us ruins, poetry, and broken pottery, it left us technology, strange, precise, almost impossibly advanced. And every few years, modern science pulls another one out of the dust and proves that we are not as clever as we thought. This is the story of 10 lost technologies. Some built things that still stand, some disappeared without a trace, and one is still being actively studied inside research laboratories today. Each one rewrites a chapter of what we thought we knew about our ancestors. It begins, fittingly, in the deep. Picture the Aegean Sea, a Greek sponge boat named the Simi. Captain Dimitrios Kontos and his men had come down to clear a winter's harvest of sponges, but a storm had scattered wreckage across the seabed. Among the marble statues, the amphorae, and the rotting timbers of a long-dead cargo ship, one diver found a lump that did not look like anything from a wreck. It was heavy, oddly shaped, and clotted with calcium. The British Museum received the lump. For decades it sat in storage, neglected and forgotten. Then in 1902, a curious researcher noticed teeth inside the corrosion, gear wheels, inside what looked like a single chunk of bronze. He began scraping gently. More gears appeared, hundreds of them, and the more he scraped, the stranger it became. What the diver had pulled from the wreck was an ancient Greek computer. Scholars today call it the Antikythera mechanism. Built more than 2,000 years ago, it could predict eclipses, track the lunar cycle, and model the motion of 5 different planets. It was roughly the size of a shoebox. A modern team at University College London took nearly a decade to build an exact replica. But the strangest part is not what it did. It is what came next, because nobody knows how the knowledge was lost. The maker's name is gone. Every textbook that described the device vanished with Rome. 500 miles west across the Mediterranean, a different kind of mystery began to harden, and it never stopped. The year is 118 CE. Roman Emperor Hadrian has just finished the Pantheon in Rome. Its dome is still the largest unreinforced concrete dome on Earth. Inside that dome, a single circular opening, the oculus, opens directly to the sky. Rain falls through it. The dome has stood through earthquakes, wars, and more than 19 centuries of weather, and it is, by every modern engineering standard, not supposed to exist. Modern Portland cement, the foundation of every modern highway and every modern skyscraper, has a working lifespan of roughly 50 to 100 years before it begins to crack. Roman marine concrete used in the harbors of the eastern Mediterranean has lasted 20 centuries. For decades, scholars assumed the Romans simply got lucky with their volcanic ash. Then in 2023, a research team from MIT published something remarkable. Inside the ancient concrete, they found tiny white chunks called limeclasts. These chunks had long been dismissed as sloppy craftsmanship. They were wrong. The clasts were the secret. When seawater seeps into a crack, it reacts with the lime and forms a fresh mineral that seals the crack from the inside out. The Romans built concrete that heals itself. We are still learning how. 1,000 years after the Romans mixed their final batch of concrete deep in the forests of southern India, blacksmiths were practicing something even stranger. They were folding swords whose internal structure scientists would not understand until the year 2006. The Crusaders called it the Blade of Heaven. When Saladin's army met the European knights on the battlefield, the European longswords bent and broke. The Damascus blades held their edge. They could slice a silk scarf dropped lightly across the steel. They bent instead of snapping. For 3 centuries, the great European smiths tried to copy them. None could. The metal was called woots. It was made in small clay crucibles in villages of southern India, smelted from specific iron ore and plant material, then folded using techniques passed down through families who never wrote a single word of their secret. When the colonial era arrived, the methods were lost. By the beginning of the 20th century, no living smith could reproduce the original blade, so researchers in Dresden put a fragment under a transmission electron microscope. They expected to see ordinary high-carbon steel. What they found was something else entirely. Inside the metal, they identified carbon nanotubes, fullerenes, and cementite nanowires, structures that modern materials science only began to manufacture in the 1990s. Medieval Indian blacksmiths had produced nanotechnology. They did not know the word. They never wrote the recipe down, but they left it behind in every sword. But that wasn't the strangest discovery. The next anomaly wasn't a weapon at all. It was a jar, a small clay jar, smaller than a coffee mug, found in the ruins of a village called Kujut Rabu just outside Baghdad in 1938. And inside the jar, a copper cylinder wrapped around an iron rod, sealed with asphalt. And when a German researcher filled it with grape juice in the 1930s, he says it produced roughly 1 volt of electricity. If true, it is the oldest battery ever discovered. 2,000 years older than anything in the modern history books. Mainstream archaeologists will tell you it was almost certainly a ritual storage vessel, possibly a sacred container for sacred scrolls. And they have good reasons. There is no inscription, no wires, no companion artifacts suggesting a current was ever drawn. Most home reconstructions on the internet use copper sulfate the Parthians did not have. Vinegar is also wrong. But Parthian culture was a sophisticated culture of metallurgy and surface treatment. Parthian smiths plated silver onto bronze for ceremonial helmets. They knew the visual difference between oxidized copper and polished copper. They knew the effect of 2 different metals sitting wet next to each other. No single jar rewrites history, but stack it next to the Antikythera mechanism, next to Roman self-healing concrete, next to nanostructured medieval steel, and a quiet clay jar wrapped in copper and iron becomes part of a pattern that does not fit our comfortable narrative of progress. Hundreds of miles north, in the 1850s, a British archaeologist named Austin Henry Layard picked a polished oval of rock crystal out of the ruins of Nineveh. Less than 3 inches wide, slightly oval. Its surface curved like a magnifying glass. He cataloged it as decorative, a bead, a trinket for a necklace. A century later, researchers in Italy noticed something strange. The shape of the crystal was almost mathematically precise. The focal length lined up almost perfectly with the workbench distances used by Assyrian craftsmen, especially ivory carvers. The Nimrud lens is now on display at the British Museum. Most visitors walk past it. Few realize they may be looking at what could be the oldest human-made lens on Earth, 3,000 years old, possibly shaped by an Assyrian craftsman who never knew he had just invented optics. If the Assyrians used it to focus sunlight, then the science of concentrating light is 25 centuries older than we say. If they used it for magnification, then the simple act of seeing something very small is older than any textbook admits. Now travel north and east, to the walls of Constantinople. The year is 673. The Umayyad fleet has crossed the Mediterranean and anchored in the harbor. They have fire arrows, they have incendiary pots. None of it works against the Byzantine navy. Then, at dusk one evening, Byzantine defenders lit something on the surface of the water. It burned on water. It clung. Roman chroniclers describe men leaping from their decks still on fire, unable to extinguish it. The wooden hulls of vessels collapsed into the harbor in seconds. The Byzantines kept its recipe for 700 years. They refused to write it down. One inventor's name survives, Kallinikos, a refugee from Heliopolis, but the actual mixture does not. Modern researchers debate whether the active ingredient was quicklime, sulfur, naphtha, pine resin, or some combination of all 4. Naphtha alone will not burn on water. Add quicklime and it can ignite. Add pine resin and the flame clings. Add a sulfur accelerant and the smoke becomes a weapon in its own right. A modest laboratory could reverse engineer something close to the original within a year, and yet nobody across 700 years of medieval warfare succeeded in copying it. When the empire finally collapsed in 1453, the secret collapsed with it. Now travel north again, to the open ocean between Norway and Greenland, to the year 1000. Viking longships crossed the Atlantic without compass, without sextant, without reliable chart. They drifted for weeks through fog and overcast. For a long time, historians assumed the Vikings simply hugged coastlines. New evidence, particularly from the excavation of a Channel Islands wreck in 2021, suggested something stranger. British sailor Tom Cunliffe demonstrated that the Viking navigators could locate the sun through heavy cloud by holding a translucent crystal of Icelandic calcite to the sky and rotating it until one of two refraction points brightened into a blue glow. They could then take a bearing from below the clouds. The crystal they almost certainly used is called a sunstone. Iceland spar forms naturally with exactly the optical property required. Medieval Norwegian tablets describe the practice. A single afternoon's training would suffice for any experienced sailor, and that disturbs the entire history of European navigation. By the time compasses arrived in Europe in the 13th century, the Vikings had already crossed the Atlantic twice, settled Iceland, settled Greenland, and reached North America nearly 5 centuries before Columbus was born. They did it with a chunk of clear stone, and finally back home. To the courtyard of a mosque in Old Delhi, a column of iron almost 7 meters tall, almost 7 tons, forged sometime around the year 400 CE by an unidentified king of the Gupta Empire. Placed first in the courtyard of a Vishnu temple long ago converted to a mosque, and it does not rust. Inscriptions on its surface are still readable 1,600 years after the iron was hammered into shape. There is no cladding, there is no coating, there is no trick, just iron. Open to the monsoon humidity of the Indian capital, refusing to decay. Metallurgists from IIT Kanpur analyzed a sample. The slag content is unusually high, the phosphorus content is unusually high. Together they create a passive corrosion layer that simply does not expand. Modern Indian metallurgists have tried to duplicate the phosphorus level and consistently fail to match it without modern refining equipment. The pillar is, in effect, a 1-ton, 7-meter experiment left on a public square. No maintenance required. 1,600 years on its feet and still reading clearly. What that says about what ancient India knew of the chemistry of iron is something modern science is still trying to understand. The final 3 objects sit at the edge of everything we assumed: a cup, a desert, a mathematician who may have weaponized the sun. The Lycurgus cup sits in the British Museum. Roman glass, 4th century CE, green in daylight, blood red when light passes through it from behind. Nobody in the 4th century could have explained why. The reason, discovered only with electron microscopy in the late 20th century, is that the glass is doped with colloidal gold and silver nanoparticles so small they interact directly with light waves. The Romans did not call it nanotechnology. They did not give it any name. They just made 1 cup, perhaps a handful, and never repeated the recipe. The cup survives because a single Christian emperor liked the image of King Lycurgus being torn apart by Dionysus, and out of a strange mercy decided the object was too beautiful to melt down. Every other example, every Roman dichroic glass that may have existed almost certainly became cullet, raw material for the furnace, through the centuries that followed. Which means 1 cup is the entire surviving record of a once-living Roman industrial tradition. Visit Peru, the Nazca Desert. For most of the year, it gets almost no rain. Then, every 50 years or so, an extraordinary flowering turns the bone-dry plain green. The flowers need water. The water comes from underground. But how in a desert? The Nazca dug an answer. Hundreds of spiral stone-lined pits, called pukios, standing in geometric rows across the valley. Each spiral descends to an underground canal, drawing water from a higher aquifer. Each canal runs for miles beneath the sand. The system is so elegant it still works. Modern Peruvian hydrologists mapped the network in 2018 and confirmed that some puquios still water the fields today. How the Nazca designed the airflow that keeps a 1-mile canal cool beneath a scorching plain they do not entirely understand, even now. The prevailing theory suggests that wind descending into the spiral stacks creates a slight pressure differential that pulls warm air out and cool air in, a natural refrigerator in the middle of one of the driest deserts on Earth, and 1,500 years old. The final object is not an object at all, it is in the mind. In 213 BCE, the Roman general Marcellus sailed a fleet to Syracuse. Archimedes was inside the city. Plutarch would later claim the old mathematician burned the invading ships with mirrors, polished bronze, focused sunlight, hulls ignited in seconds. The story has been the most famous ancient battlefield myth in the West for 2,000 years. Modern television has tried it. Mythbusters declared it impossible with bronze. A 2024 MIT student project, using modern mirrors at proper focal length, proved it possible inside a controlled test. The truth sits, by current physics, in a narrow band of yes and no. Possible with the right surface, impossible with the surfaces Syracuse would have had available. The band itself is interesting. Ancient chroniclers, several different ones, never said bronze. They said polished shields, highly polished metal shields, deliberately aligned, then walked into a focusing position by disciplined sailors on a calm harbor. That picture is terrifying, and it is not easily dismissed. So why does all of this matter? Because none of these objects stand alone. Strip the Antikythera mechanism, Roman concrete, Wood steel, the Baghdad jar, the Nimrud lens, Greek fire, the Viking sunstone, the Delhi pillar, the Lycurgus cup, the Nazca puquios, and the Archimedes heat ray out of the record, and the story we tell ourselves about technological progress becomes more comfortable and more fragile. A century that has already reverse-engineered Roman concrete in its best laboratories cannot honestly say it has nothing left to learn from the past it is not taken seriously enough to look at. The common thread is not miracle. No alien hand guided any of this. The common thread is patience, knowledge that took decades to build, then walked out of the world in a single generation, often because no one wrote it down, or the writing was lost in fire, or the knowledge lived only in muscles and muscle memory in the hands of smiths whose children were never taught. The lesson is that civilizations lose things, not by catastrophic accident, simply by forgetting. And what we today consider cutting edge, the algorithms, the materials, the medicines, could vanish the same way, no matter how confidently we file it. Final thought. Somewhere in a museum basement right now, a corroded bronze lump is sitting on a shelf. It looks like nothing. A junior researcher is quietly applying solvent to its surface, and a few minutes from now it is going to reveal a second gear,